Yeah, hello everyone. So it's day 3 of our 30 days streak challenge by Geeks for Geeks. So we'll be moving for the problem of the day today. So let's see what's the problem today. So array to BST, okay, it's marked as easy. Let's see. Given a sorted array, convert it into a height balanced binary search tree, return the root of the BST. So the meaning of height balanced is nothing but a binary tree in which the depth of the left subtree and right subtree of every node never differ by more than one. So the left subtree, we have to balance like left subtree and right subtree, right? As you can see here, the middle one is 4 and the remaining elements to the left of this 4 are in the left subtree and the elements to the right of this 4 are in the right subtree. Whereas let's say the middle element, let us consider 2, and the elements which are in the left of this 2 are in the left subtree and the elements which are in the right of this 2 are in the right subtree, right? So what we can do is like we can simply solve it. I mean, it's very easy. So let me go through the problem. So what I'm going to do, I'm just going to make a function, let's say node function, and which will be taking the parameters like array, of course, because it is required. Let's take array and let's take two variables, int I and int j. So what a function will do, it will actually take the indexes of the array and it will find the middle element of that array and it is going to make the node for that array. So let me explain you what I want to tell you. So here, as you can see, the middle element is 2, so they made it as a root node, and you can see here the middle element is 4, so they made it as a root node. So the array is actually sorted. The array is already sorted. For this sorted array, we need to make a height balanced binary search tree, right? So if the array is sorted, and we know that in the binary search tree, the elements to the left of the tree will be lesser than the, will be less, and the elements which are in the right subtree will be greater than the root node. So we are going to use that theme, we are going to use that technique to make the binary search tree. So for that, what I'm going to do, I'm just going to let's first of all calculate the mid. Let's say the indexes are like 0 and the index of this will be 6, 6, of course. 0 1 2 3 4 5 6. So 0 plus 6 by 2, it will be just 3, I plus j by 2. So we'll be finding the middle index. So after finding this middle index, we'll make the root of that. So node node is equals to new. Let's make a new node and let's call it as array of mid, because we are going to make that node. Now after this statement, what I want, the left subtree, I want the left subtree and the right subtree. For that reason, what I'm going to do, node dot left, I'm going to call for the left subtree. So what are the elements will be present in the left subtree? So the array limit will be from 0 to this mid -1. So for that reason, I'm going to call arr I comma mid -1. So till mid -1, so it means till 4, whatever the index of 4, that is 3, 3 minus 1 2. So this will be our remaining array. So 1 2 3 will be our remaining array, and 5 6 7 will be the remaining array for the right side. So I'm gonna call node dot right is equals to function of arr and mid +1, and I'm going to call for j. Done. So left part over, right part over, done. So after getting the left subtree and right subtree, I will be returning my current node. That is, let's say if it is a 4, so I'm going to return its address, that is 4. So a return node. So in the end, I'm going to just return the node. Here the steps are very simple. They have given the sorted array, so we'll be finding the mid value of that. Whatever the value present in the middle of the array, I'm going to make it as a node, and for the left part, I'm going to call for the left half of the array, and for the right part, I'm going to call for the right half of the array. So we'll be using recursion technique. And one more thing, when we have to, like, what's the base case, what should be the base case? So basically the element, whenever the I is equals to j, the loop the recursion should stop, but it will not happen in case of even number of elements. So for this, we are going to write if I is greater than j. Let's say whenever the I I value, it exceeds, I mean whenever it exceeds the j pointer, because I pointer is coming from this side and j pointer is coming from another part, another end of the array. So whenever these exceed, we are just going to return null. So it will return null and remaining part as usual. So what our function is doing, it will actually take the array, it will calculate the middle index of the array, and it is going to make the new node for that, and after that it is going to set its left part and right part. I mean it is going to get its left address and I mean left subtree and right subtree, and in the end it is just returning the root address of the tree. So what we are going to do, just return function array and I means 0th index, and along with this array dot length -1. Let's compile and run. We got some error. What's that? Cannot find symbol return function. So function, okay. Acha, so here the array name is nums, not arr. Here we made arr. Okay, fine. So just let's compile and run again. Again a new error. It's nums. Okay, what's the error? Cannot find the symbol return function nums 0 comma array. Oh, array length, not array length again. Come on. It will work actually. It's a very good problem. Let's check for the even number of elements. I hope it should work for that too. Yes, it's working. Definitely the function, I mean our code will work now. Let's check it if it passes all the test cases. 6 7 8 9 10 11. Yeah, it's working. And yeah, that's it for today. So this is our solution, and so we have solved a day 3's problem, that is to convert I mean to make a binary search tree from a given sorted array. Yeah, that's it for the day. Keep going on and we'll be meeting for next 27 days. Thank you. Bye bye.